Hi, everybody. Today we're going to talk about some inverse trig functions. Let's talk first about what we need to know from the trig packet for our next exam. Okay, there's a lot of information on that trig packet. So let me do a screen share here of the current trig packet. Okay, and so now there's 8 pages of stuff on this trig packet. Okay, I want you to do, for this test, you're responsible for the first 7 problems on this trig packet for your next test. Okay, the other stuff we're going to have for the last test. The last test doesn't have as much material from the textbook, so we can focus a little bit more on identities and equations here. Okay, so hopefully this gives you an idea of the trig problems you're going to have on this next test. Okay, we're going to look at typical problems that we'll see. Let's do a screen share of a document you should have received. Oops, I just went back to the same document. Sorry about that. Let's see. Having a few problems here. There we go. So hopefully everybody can see this. Let me go back up to the top. Okay, so this is a document you should have received a little while ago. Okay, it deals with arc sine, which is the same thing as the inverse sine of x, arc cosine, which is the same thing as the inverse cosine of x, and arc tangent, which is the same thing as the inverse tangent of x. Some people like the arc notation better than this inverse notation because sometimes people get confused with the sine minus 1x as 1 over sine of x, which is, well, in this case, that would be the cosecant. Those aren't the same thing. When you see a minus 1 with a trig function, it doesn't mean reciprocal. It means inverse trig function. Now, all inverse functions have to be 1-to-1. And so in order to make these 1-to-1, and since trig functions are periodic, the only way we can make them 1-to-1 is to limit the range values for these inverse functions. So sines and cosines are always between -1 and 1. So that's a domain. So we put a number into an inverse trig function, we get an angle out. The angle could be degrees if our calculator set in degree range. It could be radians if it's set in radian range. Okay. The range, though, for the inverse sine to make it 1-to-1 is minus pi over 2 to pi over 2, including pi over 2 and minus pi over 2. The range for inverse cosine is 0 to pi, including 0 and pi. Now, what this means is that all answers for inverse sine are going to come from the fourth and first quadrant. All answers for inverse cosine are going to come from the first and second quadrant. And an inverse tangent, well, inverse tangent would be minus pi over 2 to pi over 2, excluding minus pi over 2 and pi over 2, because tangent's not defined at those points. The range, that's the range. The domain would be all real values. Okay? Now, the same thing happens when we talk about inverse secant or inverse cosecant. Think about these as being reciprocals. We're going to look at the reciprocal of each. It's helpful to use the unit circle. I copied and pasted this unit circle from the first trig packet. It's helpful to use that when you go forward with this. Let's look at some coterminal angles. 3 pi over 2 is the same thing as minus pi over 2. That fits into that range better. 5 pi over 3 is the same thing as minus pi over 3. 7 pi over 4 is the same thing as minus pi over 4. And 11 pi over 6 is the same thing as minus pi over 6. On a unit circle, recall the hypotenuse is always 1. So the sine of theta is y over 1 or y. Cosine of theta is x over 1 or x. And a tangent is y over x because it would be sine over cosine. Let's look at an example. Cosine inverse of a half. So how do we find that? Well, since it's a half and it's cosine inverse, we're going to look for a solution in the first or second quadrant. Since it's positive, cosine's positive in the first quadrant, we look to see, since it's a cosine, where x is a half. X is a half at pi over 3. So that's our answer. Our second example, arc sine of minus 1/2. Now remember, arc sine is the same thing as sine inverse. Sine inverse, the range is defined from the fourth quadrant through the first quadrant. I look for a place where, since it's sine inverse, where y is minus a half. Y is minus a half here at 11 pi over 6, which we talked about as being co-terminal with minus pi over 6. So that would be our answer there. Tangent inverse of minus 1. Remember, tangent is y over x, so that means the y and the x have to be almost the same, except one of them has to have a different sign. So since tangent inverse is defined in the fourth and first quadrant, we're going to look for a place in the fourth quadrant, because it's negative, where x and y are almost the same, except they have a different sign. One's positive and the other's negative, and that's here at 7 pi over 4. That's coterminal or coangular with minus pi over 4. When we have something like an arc secant, we think about the reciprocal. What's the reciprocal of a secant? The reciprocal of a secant is a cosine. And so we take the reciprocal of minus 2, which is minus a half. We look at arc cosine and cosine in this case. So cosine is negative in the second and third quadrant. However, arc cosine only is defined in the first and second quadrant. So we look for a location where x, because it's arc cosine, is negative a half. It's at 2 pi over 3. So that's our answer. Sometimes we have a combination or a composite function. In this case, in example 5, we have tangent of the cosine inverse of 15 over 17, and it's negative. Since it's negative, and we're looking at cosine inverse, cosine's negative in the second quadrant. So this has to be in the second quadrant. Since we're dealing with cosines, it's an x value. So that means we have minus 15 for x. 17 is the hypotenuse. Why? How do I know that? Because remember, cosine is x over the hypotenuse. And so using the Pythagorean theorem, 15 squared or minus 15 squared plus y squared equals 17 squared, which implies that y is 8. So that means that the sine of theta is 8 over 17. How does that help? Well, remember, tangent is sine over cosine. So it's going to be 8 over 17 over minus 15 over 17, which the 17s reduce out and give us minus 8 over 15. So that means the tangent of the cosine inverse of minus 15 over 17 equals minus 8 over 15. And using a pretty similar argument as we did here in 5, the cotangent of the sine inverse of minus 8 over 17, we're dealing with a sine inverse. So that means it's in the fourth or first quadrant. Well, since it's a sine inverse and it's negative, it's in the fourth quadrant. X is positive in the fourth quadrant. Y is negative in the fourth quadrant. Sine is y over the hypotenuse. And so that means y is minus 8. So we get x squared plus minus 8 quantity squared equals 17 squared. This gives us eventually an x equal 15. Since the cotangent is cosine over sine, we put 15 over 17 over minus 8 over 17, which gives us minus 15 over 8. So this means the cotangent of the sine inverse of minus 8 over 17 is minus 15 over 8. Hopefully this helped and gave you some clarification on the trig packet. We'll see you next time.